Hello, Wolves. This is Pre-Algebra Chapter 4.2, Greatest Common Factor. In previous lessons, we found all the factors of a whole number. Now we're going to find the greatest common factor of two or more whole numbers. Let's begin. Let's begin our exploration of greatest common factor with a word problem. A choir director wants to divide a choir into smaller groups. The choir has 24 sopranos, 60 altos, and 36 tenors. Each group will have the same number of each type of voice. What is the greatest number of groups that can be formed? And how many sopranos, altos, and tenors will be in each group? We'll need to begin by finding a common factor. A common factor is a whole number that is a factor of two or more non-zero whole factors. In this problem, our greatest common factor will tell us the greatest number of groups that can be formed in our choir. There are two different methods that we can use to find the greatest common factor. In method 1, we simply list the factors of each number and then identify the greatest common factor. So we'll begin by listing the factors of 24. They would be 1, 2, 3, 4, 6, 8, 12, and 24. Now we'll list the factors of 60. They'll be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. And finally, we'll list the factors of 36, which will be 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, now our next step is to identify the common factors. I'm going to underline our common factors in red. They are 1, 2, 3, 4, 6, 12, and that's it. So our greatest common factor between all three numbers is 12. We can form 12 groups. Now let me show you method 2 for identifying the greatest common factor. In method 2, we'll write the prime factorization of each number. The greatest common factor is the product of the common prime factors. For example, the prime factorization of 24 is 2 times 2 times 2 times 3. The prime factorization of 60 is 2 times 2 times 3 times 5. And the prime factorization of 36 is 2 times 2 times 3 times 3. Now we identify the common prime factors. We have a set of 2's. We have another set of 2's. And we have a set of 3's. So to find the greatest common factor, we'll take 2 times 2 times 3, giving us 12. So the greatest common factor of 24, 60, and 36 is 12. Now we have to answer the second part of our question, which is, how many sopranos, how many altos, and how many tenors will be in each group? If we can create 12 groups of musicians, then each group will include 2 sopranos, 5 altos, and 3 tenors. And there you have it. Now try some of these on your own. Find the greatest common factor of the numbers listed in problems 1 through 4. You may use either method 1 or method 2, whichever you prefer. Remember, in method 1, you list the factors of each number and then use those listed factors to identify the greatest common factor. In method 2, you write the prime factorization of each number and then find the greatest common factor by finding the product of the common prime factors. Now let's introduce a new term. It's called relatively prime. Two or more numbers are relatively prime if their greatest common factor is 1. So the two numbers may or may not be prime numbers themselves. What makes them relatively prime is that their greatest common factor is 1. Let's examine 35 and 54. Let's find the greatest common factors and then decide if the numbers are relatively prime. I'm going to begin by finding the prime factorization of each number. That's the technique I prefer to use. If you prefer to list factors, that's totally okay. But I'm going to use the prime factorization technique. So the prime factors of 35 are 5 and 7. That's it. So 35 equals 5 times 7. The prime factorization of 54 is, let's see, 2 and 27, which gives us 2 and 3 times 9, 2, 3, 3, 3. Okay, so 54 equals 2 times 3 times 3 times 3. Uh-oh, look at here. They don't share any common prime factors. However, each number can definitely be factored as 1 times itself. So 35 and 54 are relatively prime. They share 1 as a common factor, and 1 only is the common factor. Let's look at another example. 24 and 45. Once again, I'll prime factor these. 24, our prime factorization of 24 will be, let's see, 2 and 12, 2, 2, 6, 2, 2, 2, and 3. So 24 equals 2 times 2 times 2 times 3. Okay, now let's do 45. Let's see, 45 will be 3 and 15, 3, 3, and 5. Okay, so 3 times 3 times 5 equals 45. So our two numbers do indeed share a prime factor. It is 3. So the greatest common factor of 24 and 35 is 3. It is not relatively prime. It has a common factor other than 1. Now try these problems on your own. Find the greatest common factor of these numbers, and then tell me whether their numbers are relatively prime or not. Press pause while you work, and when you come back, we'll finish up with the final thought for this lesson. In Chapter 4.1, we learned about monomials. Now let's figure out how to find the greatest common factor of monomials. Let's begin with this example. 18xy squared and 28x squared y squared. So how would we go about finding the greatest common factor of these two monomials? Well, the first thing we'll do is to simply factor the monomials, just as we would a regular digit. So we'll start with factoring 18, which is 2 times 3 times 3. Now we pull out our variables, times x times y times y. So 18xy squared factored is 2 times 3 times 3 times x times y times y. Now let's factor 28x squared y squared. 28's prime factorization is 2 times 2 times 7. Now let's factor the variables x times y times y. Now, just as we would with any other regular digit, we're going to look for our common prime factors. We have a set of 2's, we have a set of x's, and we have 2 sets of y. So now we'll rewrite this as the greatest common factor, which will be 2xy squared. So the greatest common factor of 18xy squared and 28x squared y squared is 2xy squared. And let's close out Chapter 4.2 by factoring these 4 sets of monomials on your own. Find the greatest common factor for each pair. When I see you tomorrow, we'll check over our work and do some more practice on finding greatest common factors. Have a great night.